Good morning everyone. In today's session we'll discuss about what are Bitcoin scripts. So basically speaking, what is meant by a transaction in a blockchain network. So when you say there's a transaction, there are two parameters. One is what goes into the transaction, we call it as the input, and at the end of the transaction what happens, the output of the transaction. So you'll have to determine that the transaction input is currently claimed as a transaction with the transaction output also. So that is very important. So what's meant by a script? A very simple, compact, mini programming language which can be used to validate the Bitcoin transaction. So basically, it has got a list of instructions. If you send one instruction, for example, I am sending 500 rupees to uh, Mr. Rajit. So what's the transaction from Tenmuri to Mr. Rajit? An amount of rupees 500. Okay, so this is the list of instructions that is recorded with every transaction, and the script will actually have some parameters which will help to validate the Bitcoin transaction. Next, it describes how the public key and private key interacts with each other during a transaction. It's a forth-like language, stack-based, and it is processed from left to right. So, what's a fourth language? It's actually a stack-based computer programming language. It was originally designed by Charles Moore. It's a procedural programming language, but doesn't involve type checking. And in order to verify whether that particular script is okay, it uses a stack. I think all of us know stack. Uses a stack for recursive subroutine execution and uses RPN, reverse polish notation or postfix notation. Let us look into the simple example. So in case if this is the stack and these are the values that are given, 30, yes, pushed inside. Then comes 10, yes, it's dropped inside. Then comes the star. Once it mixes, so these two values are multiplied and it's popped up, so 300. And then comes 15, then that is added on top of it. So as and when it sees the elements, so that's pushed into the stack, and if it meets with any operator, it performs that operation and it pops up the value, right? So after 15, here comes the plus operator. So 300 plus 15 gets 350. And when we say CRS, let's look at the current value. The value is popped up saying it's 350. So this is an example of how a stack can be used to evaluate such expressions. So let's look at a simple fourth code. Okay, and it's equivalence C code. So there's a function called float file, and it says like it takes an input of n, which is of integer type. If n is less than 6, it will return the value 5. Yes, it will return n minus 1. So the equivalent float code is, this is actually the function. Float file is the function, and then comes n minus minus n dash, duplicate 6 less than if, drop 5, else 1 minus 10. See, float file that we saw, no, that's the name of the word being defined. This check is actually used, n minus n dash is actually used to describe what the word is expecting on the stack before execution and what it leaves after execution. So here what happens, n represents the input value and n dash represents the modified value that will be left on the stack. Whenever you come across this word dup, whatever is on the top of the stack, it will duplicate. So after this instruction, if you look at the stack, if there is value 5, okay, and I say dupe, it will create another one value 5. So after this operation, the stack will contain 2 copies of the same value. Then we saw this 6 less than if. This is a check to see that if the duplicated value on the stack is less than 6. If the value is, we saw another one keyword drop. If the value is less than 6, then this word discards the top value from the stack. So which means it effectively removes the duplicated value. Then we saw 5, another one number. If the value is less than 6, then the code pushes the value 5 onto the stack. What is meant by this else command? If the value is not less than 6, then the execution continues here. We saw the last was 1 minus, so it just tries to subtract one value, 1 from the duplicate value on the stack. The keyword then marks the end of conditional block. So you see if else, if then else, right? Similar to that. So when you look at the transaction, see there's 100 Bitcoin coming inside, and once I get 100 Bitcoins, that's the input that I got. I'm going to spend it. In one transaction, I'm sending 40 coins, okay, to person A, and 60 coins to person B. So one transaction will have an input, and it has this output also. If you look at this diagram, at any point of time I can trace back, say out of this 40, when I gave to my friend Asha, she has spent again 30 Bitcoins to someone, and she owes only 10. And when Charles received this transaction, 330 Bitcoins, he is spending 10 to someone else. So at any point of time, you can just go across these arrow marks and find out who owns how much. So transaction in blockchain can be characterized by the input and the corresponding output. You can represent the Bitcoin transaction in the form of series of inputs and outputs. Now we'll see what all components come here. For an example, if Alice wants to make a transaction with Bob, Alice is initiating a transaction with certain amount that contains the address of Bob and Alice, similar to sending a mail. I compose a mail from my mail ID to my friend's mail ID, from my bank account to my friend's account, as simple as it is. So from Alice public key, so to Bob's public key, right? So this transaction will have two parts. One is Alice public key and the signature. See, when there is a username, there is always a password, right? So Alice has a private key, a password with her, and with that she is generating one signature. And on the other hand, Bob should verify who really sent me that money. Bob should verify. If Alice public key is available, account number and email ID, then Bob will know that I am the one who sent the mail, right? So Bob can verify the signature and he can be sure that transaction has been actually sent by Alice, number one, first point. Second one, it is a valid one. What Bitcoin has done that is, instead of sending the public key and the digital signature, it is sending some scripts, like some commands, and it says you validate. So Bitcoin uses two scripts. One is corresponding to the signature. We'll call it as, since it's script signature. That's all. And another one is corresponding to the public key. So adukku per enna script public key. That's all. Only two. So these scripts, they don't support all the operations like a loop. The basic intention is the program should be very simple. So whenever I write a transaction, whenever I make a dealing, Alice should provide, number one, the public key. என்னோட மெயில் ஐடிலேருந்து அனுப்புகிறேன்ல அந்த மாதிரி ஒரு public key. அந்த public key வந்து hash பண்ணா, it should get the address of Alice which is embedded in that script. Next should be able to see the signature, a signature to provide ownership of the private key corresponding to the public key of Alice. See, I have used the public key. I have a password, right? So I will be signing, I will be generating a signature just to prove that I am the one who has initiated this transaction. So if you look at this example of a Bitcoin script, there are two components. One is script public key and the other one is script signature, right? So if you want to make a transaction, the script for it would be like this. All the above content is a simple Bitcoin transaction of the type P2P KH, pay to public key hash. And this type of script is a standard script and the most used way to send bitcoins. We learn this now. So we saw two inputs, right? One is script public key and script signature. At time, initially there are the actions. Okay, these are the actions to be performed. While the second is containing the signature and the public key to verify the authenticity. Who really sent it? See, script signature, and this is public key. Every script will contain some data like public key and signature, some operators, some opcodes. So we'll take these two elements. As we saw, script public key has op duplicate of hash 160, public key hash of equal verified of check signature. So these are the opcodes. The second element is script signature. Okay, it has got two values. One is signature, the other is public key. So basically speaking, the stack is initially empty and both the scripts are combined. How will you combine the input followed by the output? So this is the input followed by output. So this goes inside signature, then comes one value public key that also goes inside. And next comes this op dupe. What does it mean in op dupe? It has to create a duplicate of the topmost item in the stack. Topmost item public key. So I will get another one public key. Yes, done. Next comes of hash 160. So it's telling, see, find the hash value. So for that public key, a hash is now obtained. Right. And the next is, there's a value here that is pushed here, pub key hash. The concept is pushed. Now comes another code. See, it's telling check for equality. There are two items here, pub hash and pub key hash. Check for equality. Right. So it is checked if both are equal. And then the last one is operator check signature. The signature is checked based on the top two stack items. We already had a condition true. Yes, the previous slide says like I'm going to compare those two and I've got the value is true. Now the signature is checked based on the top two stack items. So this is how when you implement a set of scripts which has these commands, it makes use of a stack and performs this operation. So what happens during script execution? First, the original public key of the owner, script signature, right? It's duplicated. The duplicate public key goes through a hashing process and a hash is applied at first. The result of the hashes is compared, equal, verified. Why do you want to verify? To make sure it is the same key and it is as well verified. If it matches, the script will continue to run. And then it will see where to check the signature. Check signature is performed to verify the signature with the public key. So basically looking into its Bitcoin script instruction. There are totally 256 opcodes which performs arithmetic, if then, logical, and then data handling. When it comes to the cryptographic functions, it makes use of hash function, signature verification, and multi-signature verification. So basically speaking, the lock, right, the locking script can be found in the output of a transaction, while unlocking script can be found in the input of the transaction. The next is about to know how to join in a Bitcoin network. That is actually covered in the forthcoming lectures. Thank you.